Now we cover section 6.3, routers, of chapter 6, network layer. Okay, a router is a computer. Regardless of their function, size, complexity, all routers models are essentially a computer. Just like computers, tablets, or smart devices, routers also require operating system, CPU, random access memory or RAM, read-only memory, ROM. A router also has a special net memory that includes flash and non-volatile random access memory, NVRAM. So, router memory. A router has 4 types of memory: RAM, random access memory; ROM, read-only memory; non-volatile RAM; and flash. So on RAM is volatile. When you think of volatile, the meaning of volatile means that it needs electricity, it needs power to keep the memory, to keep the data on the memory. Non-volatile means that it doesn't need the electricity, it doesn't need the power to retain the data. For example, think of non-volatile, your USB. USB doesn't need any electricity to retain all the data, but the RAM does. So we have RAM, ROM, NVRAM, and flash. RAM is volatile. ROM, NVRAM, and flash are all non-volatile, so they will retain all the information even when you switch the device off. On RAM, we have running Cisco IOS. So IOS is copied into RAM during the boot. So IOS is stored in flash, which is non-volatile. You switch the router off, your operating system is there. As soon as you switch the router on, the operating system is copied, or IOS is copied from flash into RAM. Now it's called running IOS, so it's stored there. Same with the PCs as well. If all your Windows 7, 10, or whatever you have, 8, Vista, it's retained on the hard disk when the computer is off. When you switch the computer on, it goes and reads from the hard disk the operating system, and the whole operating system is copied into RAM. So your whole operating system is running from RAM. Then we have on RAM, we have running configuration file as well. So any changes that we run is on the RAM. It's called running configuration file. On NVRAM, we have a startup configuration file. For example of this, think of a document that you have in Notepad or Word or so on. That document, you write something and you save it. It's there. If you close the machine, if you close the computer, it's always going to be there. When you open the computer, you open the document. Now it's a running document. When you make changes, it's still just running. You haven't not saved the changes. That's called running configuration file. So the configuration file is running. You haven't made the changes. You made the changes, but you haven't saved them. As soon as you save them, it's saved on the startup configuration file. So when you close a router, next time you boot, it goes and reads the NVRAM and reads the startup configuration file. On RAM, we store the IP routing table, is stored there as well, and ARP cache. This cache contains the IPv4 address to MAC address mapping, similar to a ARP cache on the PC. And we have a packet buffers as well. Packets are temporarily stored in a buffer when received on the interface or before they exit the interface. So RAM, remember, it's volatile, so it needs power to retain the information. In there we have the running IOS, Inter-Network Operating System, running configuration file, anything on updates on the routing table, any updates on the ARP tables, like MAC address to IP address information, and any packet buffers as well. Then we move on to ROM, read-only memory. Cisco routers use ROM to store the bootup instructions. The bootup instructions, they provide the startup instructions, what to do. Once a router boots up, goes and reads the ROM, bootup instruction, hey, ROM, what do I do? What's my next job? In there, we have a basic diagnostic software that performs power on self-test of all components. Power on self-test, you should know, is all the computers they do. As soon as you boot them up, they test everything. They test the memory, they test the motherboard, they test all the devices, making sure that everything is there, working and performing well. Not performing well, but they're working. And in ROM, we have a limited IOS, provides a limited backup version of operating system, in case the router cannot load the full-featured iOS. So ROM is a firmware. I think this is a limited iOS is if, for example, your operating system is corrupt, you still have a limited version of our operating system, so you can restore, you can troubleshoot or install a new operating system. So ROM, think of it like a BIOS, yeah, on the PCs. Where the BIOS is always going to be there. The instructions there is non-volatile. Everything, all the configuration there is non-volatile. It means that it will retain if there's no power. Then we have a two special type of memory on the routers. So we have NVRAM, which is again non-volatile, and this is NVRAM is used by the Cisco IOS as a permanent storage for the startup configuration file. Like ROM, NVRAM does not lose its content when the power is turned off. And then the last one, we have a flash memory. Flash memory is non-volatile computer memory used for permanent storage for the iOS and other system-related files. The iOS is copied in from the flash into RAM during the bootup process. So think of a flash memory as a storage area, permanent storage area, like your SSD and your computer. Cisco IOS operation details vary on different internetwork devices, depending on the device purpose and feature set. Now, think of iOS as, there's a different iOSs for you to purchase or to have. There's less featured iOSs, like 11.0, 12.0, so on. The latest one is 15.0, 15. iOS 15. Now, the iOS, think of the features as extra features you will buy with the new version of operating system. For example, if you compare Windows 10 with Windows XP, Windows 10 gives you a lot more features than Windows XP. Same with iOS. Higher the iOS, it's better, more features. Cisco doesn't use names on the operating system. Cisco uses numbers. So the latest number is 15. Then you have 15.0, 15.1, 15.2, and so on. All these are like service packs or updates, patches. All the Cisco IOS of routers provides the following. We can address the devices. We have the interfaces that we can send the package to and from. Routing, we provide the Cisco routers. Well, that's the job, to provide routing, how to send the packets from one network to another network. Can provide you security through use of access control list. Quality services, you prioritize some packets over some other packets, and then resource management as well. So router loads following two files into RAM when it's booted. So when you boot, the iOS is copied, or operating system is copied from the flash, from the permanent storage into RAM, the whole iOS. And then the startup configuration file is copied as well from NVRAM to RAM as well. When the iOS is copied from flash into RAM, it's called running iOS. When the startup configuration file is copied from NVRAM into RAM, it's called running configuration file. The router bootup process, there are three major phases on the bootup process. The first phase is the router is going to go and perform the post. Power on self-test. Like as we said, it's going to check test all the router hardwares. After the post, the bootstrap program is copied into ROM, from ROM into RAM. Once in RAM, the CPU executes the instructions in the bootstrap program. The main task of the bootstrap program is to locate the Cisco IOS and load it into RAM. So it's asking the bootstrap what to do next. The bootstrap says, okay, well, go to flash. Your job is to load up the iOS. You can find it from flash, or you can find it from TFTP server. At this point, we should see that in the console, we should see some kind of messages connecting to the router. You should start seeing some output. Number 2 is locate and load the Cisco IOS. The operating system is typically stored on flash, and it's copied from flash into RAM. During the self-decompression of the Cisco IOS image, a string of pound signs will be displayed. Now, the iOS is stored as a compressed version because obviously we don't have enough, place in the RAM, or enough big enough RAM to store the iOS. Maybe it's usually stored in the compressed version. So when you boot up, the iOS is decompressed and then copied from flash into RAM. If it's not found in the flash, the router will look at the TFTP server. You can store the iOS in TFTP server as well. And then the third step is to locate and load up the startup configuration file or enter the setup mode. The Bootstrap program then searches for the startup configuration file in also known as startup config in NVRAM. If it's not on the NVRAM, if it hasn't found anything there, you will go to TFTP server. You will try and load from the TFTP server. If the startup configuration there is not on the TFTP server, you will see have a message. Do you want to enter the setup mode to start configuring? Now, show version output. The show version, you can use the show version command to verify and troubleshoot some of the basic hardware and software components on the router. The command displays information about the version of Cisco IOS software currently running on the router, the version of Bootstrap program, the information about the hardware configuration, including amount of system memory. Now, show version is a great command. It's really, really good command. Imagine that you have a router that you want to sell. The first thing you would do after you take a picture and put it on eBay or whatever, you run the show version. With the show version, the person who's buying it can pretty much see everything that router is capable of. What is the CPU? How much memory does he have? What kind of devices? What kind of interfaces does he have, and so on. iOS version of the Cisco IOS software in RAM, and that is being used by the router. And ROM Bootstrap program displays a version of the system Bootstrap software stored in ROM that was initially used to boot up the router. The show version is a location of iOS, displays the Bootstrap program is located and loaded in Cisco IOS, the complete file name of the iOS image, the amount of amount of RAM and the CPU. The first part of the line displays the type of the CPU of the router. The last part of the line displays the amount of dynamic random access memory. Some series of routers, like 1941 integrated service routers, use a fraction of DRAM as a packet memory. Packet memory is used for buffering packets. To determine the total amount of RAM, we need to add both of them together. Then interfaces displays the physical interfaces on the router. In this example, the Cisco 1941 ISR has 2 gigabit Ethernet interfaces and 2 low-speed serial interfaces. The last thing we will see is the amount of NVRAM and flash. This is the amount of NVRAM and the amount of flash memory on the router. NVRAM is used to store the startup configuration file, and used to permanently store the flash is used to permanently store the Cisco IOS. The last thing we see is a configuration register. There are several users, including password recovery. Now, the configuration register is what to do. The router is going to go and read the configuration register, saying that what is my behavior. What am I going to go? What's the steps I'm going to take? Now, the default config register is 2102, which says go to flash, read the iOS, then go to NVRAM, read the startup configuration file. For example, if in the startup configuration file you have a password that you need to recover, you need to change this register from 2102, for example, to 2142. And those steps, it will say, okay, well, now go and read the flash. Once you load the iOS from flash into RAM, don't bother with NVRAM. Don't read the NVRAM. Okay, on this demonstration, I will show you the boot process and show version command. Now, this is on the GNS again, so it's a bit different to the physical routers. If you have a physical router, you will see a bit better, not better, but different kind of behavior. So what I'm going to do, I'm actually going to reload this router, so we'll see the startup. So right click there and reload. And this is the load of the router. Again, this is the simulator of the GNS, so it's a bit different to the actual physical router, because the iOS is already decompressed, so you're not going to see this pound sign flying by. Okay. Usually quite fast, but here we can see quite a lot of information as well. Anyway, you can see what is the operating system I'm running, what is the version. Sorry, I'm still waiting. Then I can see my interfaces. I've got 2 fast Ethernet interfaces. I can see the flash and NVRAM as well. Okay, that's a boot. So show version. Again, this is because it's on the virtual, is a bit different. What we can see here, we can see the iOS that we're running. What kind of iOS we're running? What is the version? We can see where did we get the image from. The CPU that we're running. What is the model? Making the model of the router. How much RAM do we have? So we can see that this is splitting as well for the packet memory as well. So we have here. So we have to add those two together to get how much RAM we have. What else we can see? We can see the interfaces. We have 2 interfaces. We can see the flash memory where we store the iOS and the NVRAM memory as well. Plus we can see the configuration register that is set to the default 0x2102, which again it says we have to follow the correct order or the default order of the boot in the router. So we need to change this to 2142 if we want to, this 0 to change it to 4 if we want to ignore the NVRAM. Okay, that's it for the section 6.3. I'll see you on the next section, which is 6.4.